Good afternoon, everyone. Oh, sorry. Hello, hello. Good afternoon, everyone. Am I audible? Check. Hello, 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 hello,
Yes,
hello.
ma'am.
Okay, hello.
Yes, ma'am, you're audible.
Okay. So where we were, bending moment. Okay. Is my screen visible? I hope so. Yes.
Yes, ma'am. Screen is visible.
Now we will talk about the maximum bending moment. The in the first class we have talked where we have the maximum load and we have to calculate that maximum load. So when we know where it is, we can calculate from the reactions, we can find out the reactions. Okay. So and also where is the maximum shear force on the gantry girder, we know the position. Now where will be your maximum bending moment, and how you can, once you know where it is, you can calculate the bending moment. You can calculate the, after knowing the reactions. So if I say this is your gantry girder, here you will have the reactions. This was the reactions were A and B, RARB, because we took to be the gantry girder to be A and B. Okay. Now this entire thing is this one. So if we give a straight line here, this is the center, suppose. Okay. Now if I take my pencil, okay. So UDL is here. This is the gantry girder here. So this is your span of the gantry girder. This is the center, and here this will be your, suppose the reaction will be RA, because the point was A there. This is RB. Okay. Now since this is the center, this both will be half. Suppose if this is your L, span of the gantry girder, if we take it to be L, okay. If we take this to be L, our this will be L by 2. This one will be L by 2. This will also be L by 2. L by 2. Here also L by 2. Okay. Now here if I this one, this is your self weight of the gantry girder plus your rail weight will also come because the rail is above the gantry girder, right? So this UDL over the gantry girder will be the self weight of the gantry girder as well as the rail sections which are above the gantry girder. Okay. Now your bending moment, where in the gantry girder, where is your maximum bending moment is, see, this is your center. Okay, so if I take another line and take this color to be suppose blue, this was your center. Now suppose your wheel is here. Okay, it's very difficult. Sorry for this. Everything got erased. These are your reactions of the gantry girder RARB. Then we have so if we give this entire thing here is your span of the gantry girder. If we take again, this is your center. Suppose this is the center of the gantry girder. Okay. Okay. This will be your, this is your L by 2. Here again, this is your L by 2. Right. So this is your UDL. This is your self. This was your self weight of the gantry girder plus your rail section. Kilonewton per meter. This was your RA. RA. This was your RB. We have L by 2. L by 2. This is L. So now suppose your The rail section is here, okay, here. Above the gantry girder, you're having the rail section where the crane is moving, crane girder is moving, right? So, if this is your center C, suppose you have this one and this one, okay. Hmm. You have the wheels here. Okay, the wheels of the crane girder, which is above the rail section here. This is your gantry girder, which I told you in the first class. If this was your gantry girder, you have your rails crane girder here. Trolley was also somewhere here. Okay, it is moving from here to here. So this was your gantry girder. These are your gantry girders. This one and this one is your gantry girder. This is your crane. Now the crane is moving on the gantry girder in this way. This crane girder is moving above the gantry girder. So these are the two wheels here which are moving. That means the rail sections which are above this, these two wheels are moving. So these two are these wheels. Okay, the wheels of the crane girder here. So this one and this one. Okay, now the center of these two wheels, that means here if these two are the crane girder wheels, here this is the center here, from somewhere here it will come this side. So here somewhere here will be the center. So suppose your center of the wheelbase is, suppose this is your center of the wheelbase. Okay, this wheelbases we had found out the reaction. This was the crane girder. We had calculated the maximum load here, maximum loads here at this corner, because there was an approach here, minimum approach, where your this what is that called, the crab, which is your the trolley, it will be here somewhere, the constant place where it is going to come and stop. We know this one near a minimum approach. So we had calculated the maximum load here. Hmm. We had calculated the maximum load on the crane girder, which was RC, because RC and RD. So this side we had our maximum uh, reaction RC. So these wheel loads will be divided. That means that load, maximum load, will be divided here among these two wheels. So that will be, that we can say it to be RC by 2 here, and it is RC by 2 here. Okay, that RC, the maximum load which we have got, that will be divided in these two loads. Okay, the maximum load which we have got, that will be divided in these two loads, these two wheels, RC by 2, RC by 2. Now this is the center of the wheel. That means this is the wheelbase. Okay, this is your wheelbase B. Wheelbase means the distance from this to this, from this to this wheel to this wheel, the distance is B. So if I, okay, if I show you here, from this to this is your wheelbase. Okay, WHWL wheel base. That means nothing but, suppose we give it to be B. B is equal to your wheelbase. That means this is your wheelbase, the distance between the two wheels, and this is the center here. This is the center of your this gantry girder. Okay, let me write it here. L is equal to span of the gantry girder. Okay. So your this L was your span of the gantry girder. This is the center. Now, where is your maximum bending moment occurs in a gantry girder? That is when this is your center of the gantry girder. This is the wheelbase B. This is the wheelbase B, and this is the center of your wheelbase. That means B. That means this will be B by 2. So from here to here, it is your B by 2. From here to here, it is your B by 2. Okay. B by 2, and this is also B by 2. Okay, B by 2, B by 2, because this was B, this wheelbase was B. Now, where is your maximum? Your maximum bending load will be from the center of the gantry girder. This center, you have to place your this wheelbase of this crane girder in such a way that, um, because you are finding out the maximum bending moment, and where is your maximum bending moment, your maximum bending moment is there when you place your this wheelbase of the crane in such a way so that your this center, the distance from this center of the gantry girder to the nearest wheel, and the distance from the center of the gantry girder to the center of your wheelbase should be equal. Okay, understood? Take listen carefully that your maximum bending moment, you will calculate your maximum bending moment in that position. That means you will place your this wheelbase of this two crane girders in such a way so that your the distance between the center of your gantry girder and the distance of the nearest wheel and the distance of your center of the wheelbase will be equal. That means what I'm trying to say is that, suppose I take this to be blue. Now, this distance from here to here and from here to here, okay, this distance, it is like that. This will be how much now? This will be your, because since this was your B by 2, right? This distance from this center of your this wheelbase to the wheel, one of the wheel is B by 2 here, and this is also B by 2 since this is the center of the wheelbase. Now, this wheelbase will be divided in two. That means from the center to the nearest wheel, it should be B by 4, and this also should be B by 4. Understood? Your wheelbase should be placed in such a way so that the center of your gantry girder is at a distance, the distance from the center of your gantry girder to the nearest wheel, and the distance of the center CG of the wheelbase should be same. Okay, so we have placed our wheelbase of the this crane girder in such a way so that this distance, this both distance is equal. That means now if how this will be equal, B by 2 we know, so B by 4 we have to divide this two in B by 4 and B by 4. Now you can see your distance from the center of your gantry girder to the nearest wheel and the distance from the center of the gantry girder to your center of the wheelbase is same. Okay, it is either way. If you place, suppose if your this wheel would have been nearer to this center CG of the gantry girder, then from this side you would have done. Okay, that means your this two wheels would have come here, your this first wheel would have come here, and your this second would have wheel would have come here. So this would be the nearest to the wheel, the CG to the nearest wheel, this would be B by 4 and B by 4 for this particular wheel. But now since we have placed in this way, so the bending moment, maximum bending moment always occurs here. Okay, you will place your gantry girder in to find the maximum bending moment. You will place your wheels of the crane girder in such a way so that your distance from the center of the gantry girder to the nearest wheel and the distance of the center distance from the center of the gantry girder to the center of your this wheel base is same. Okay, now since it is same, so here we will get our maximum. That means on this wheel we are going to get our maximum wheel load, and sorry, the maximum bending moment will be here at RA. If we point this to be, if we take it to be, suppose uh, this to be A, this wheel to be A, and this wheel to be B. Okay, so our maximum bending moment will be here, which is nearer to the center of the gantry girder here. Okay, so once you know this distances, you and you know all the reactions also, you already had calculated, so you will know the reactions, you will know the spans, you will know this distances. You can find out, or you can calculate the this thing, the maximum bending moment. Okay, done. So in this way we are calculating our maximum bending moment. So now if you see this entire RA by 2, RA by 2, this was RC by 2. Okay, means maximum bending moment will be here in this wheel, which is B by 2, where we have RA by 2. And here, okay, done. So this is how you calculate your maximum bending moment. To calculate the maximum bending moment, you have to know your maximum, or sorry, the position of the places of the maximum bending moment which occurs. Okay, one second, exams are going on. Hello, actually now I'm in a meeting. Can you call me after a few minutes? Please, after 25 minutes, 30, 25 to 30. Okay, okay, thank you. Okay, okay. Hello, okay. So this was your maximum bending moment at RA. Okay, I'll now if I move, okay, if I move down to a problem now where we have to calculate all those things. Okay, let us start with a problem now. Okay, so now this I'll just remove these things, because if I go down, I think all these annotations will go. If you want to take a screenshot also, you can take now. So okay, we'll move to a question. Hmm, okay. This is a question on gantry girder. Okay, now what see the question. If you see the question, it says design a gantry girder for the following data where crane capacity is 200 kilonewton. That means the crane capacity is given to you, how much load it can take your crane with the, that means including the load of this thing, the your trolley. Okay, so your span of the gantry girder is given to you 7.5 meter here. Span of the crane girder is given to you 15 meter. Okay, so sulphate of the crane girder excluding the trolley is 200 kilonewton. Sulphate of the trolley is given to be, okay. The here the crane capacity excluding the trolley is given to you. Okay, so sulfate of the trolley is given separately here, which is also called to be, this trolley is also known to be your crab. So 40 kilonewton it is mentioned here. And the minimum hook approach, I told you about the minimum hook approach. That means where your the trolley or the crab is constant, where beyond that it cannot move beyond that to the edge. Okay, so it has to maintain a minimum hook approach of 1 to, sorry, this is 1.2 meter. Okay, not 1 to 2, this is 1.2 meter. The minimum hook approach is given to be 1.2 meter. Next, what is given, wheelbase of the crane is 3.5 meter. Wheelbase is given to be 3.5 meter. We know wheelbase, just now when I was talking about the bending moment, wheelbase, I talked about the wheelbase, which is your crane, the wheelbase, wheel of the two legs of the crane together. So that is 3.5, distance between the two wheels of the crane, 3.5 meter. Sulphate of the rail section is given to you. Rail section which is above the gantry girder and above which the crane moves. Okay, that is sulphate is how much of the rail, sorry, rail section, this one 300 kilonewton. Sulphate of the gantry girder is given to be 1.6 kilonewton per meter. Weight of the rail section is 0.3 kilonewton per meter. Take yield stress of the steel to be 250 megapascal. Okay, so this, from the figure, from the question, we can draw this thing, our whatever is mentioned to us, if we draw then it is better for us and clear. Like this is your gantry girder, you know, this one I1. This is your, if you see the top view, this is your gantry girder, this is your crane girder. Okay, this is your crab, that means the trolley. These are your wheels here, and these are also, these two are also your wheel. You can see here the wheels of the crane girder, here the wheels of the trolleys are also there. Now, and minimum hook approach was mentioned in us in the question to be 1.2 meter. That means this distance, beyond this distance this trolley cannot move beyond this distance. It cannot come here, which has a distance of 1 meter. It is 1.2. Its minimum approach is given to be 1.2. Okay, it cannot go beyond this, but it will stop here. Anytime it is shifting loads from here to there, it has to stop here. So we know a constant position, so we find out the maximum load here. Okay, so this is 1.2 meter. Our this is given to be 3.5. The distance between these two wheel loads, wheelbase is given to be 3.5. This one, wheelbase of the crane is 3.5. So 3.5. This is the span of your gantry girder, and this is the span of your crane girder, which are given to you. Span of the gantry girder is 7.5 meters. Span of the crane girder is 15 meter. Okay. So this is your span of the crane girder, 15 meter. This is your 7.5 meter. Okay. Now this is 15. I told you this is 7.5. Okay. Anything else? Anything else is not mentioned in approach we have taken. Trolley, this that the loads we are going to calculate. Okay, fine. So we have these things. From our question, we got these things. Okay. So first of all, what we are going to do, we are going to find out the maximum wheel load. So this is your maximum wheel load. The first step is to calculate the maximum wheel load. Okay. So in our question, we had been given the crane capacity. Okay, so crane capacity is nothing but the load of the crane, load on the crane, or the self-weight of the crane also you can say. But we need the total load which is acting on, because the maximum load, we are calculating the maximum load. So maximum wheel load will be what? This crane capacity, the capacity of the crane, how much load it can take with the including the self-weight of the crane itself, and also the weight of the trolley, because the weight of the trolley is going to be over the crane capacity, that means crane. This one, you have your crane, sorry, gantry girder, This is your crane girder, or the other way you can take crane girder. So trolley will be here. So trolley is here. So the self-weight of this crane girder as well as the trolley weight is on the crane. So we will add the crane trolley weight also. Okay, so this is the total maximum, sorry, not maximum, but this is the total load which is of the crane girder. Now again the self weight of the crane girder, yeah, it is 200 kilonewton. Since we know the self weight of the crane girder is 200 kilonewton, also now we can calculate how much is the per meter of weight of the crane girder. So we had the this crane girder was how much, 15 meter. This was 15 meter. So 15 meter, 200 by 15 is equal to 13.33. Okay. So we got our UDL, or that means the per meter weight of the crane girder to be 13.33 kilonewton per meter. That means okay, I'll draw it in next page. Okay, there is no place. Okay, I'll show it here. So this is your crane girder. Okay, you have this reactions here, RC, RD. This is suppose your RC. This is your RD. Since this point of the crane girder is C and D, if you think gantry girder, if we assume it to be A and B point, so this is the point C. This is point D, suppose. Okay. Now we have a this distance is how much? The distance of the crane girder, the span of the crane girder, this span of the crane girder is given to us to be 15 meter. Okay. Now we know one more thing. The now this is the crane. We will have the trolley. Okay. So the trolley had a distance approach, minimum approach was there. That was in your question. It was how much? That was 1.2 meter at a distance of, suppose this is, if this, suppose this is at a distance of 1.2 meter. This is 1.2 meter. Now this distance is 1.2 and the load here it was given to be how much? 240. We had just now calculated here the the crane load plus the trolley load, 240 kilonewton. Just now we had calculated in the first step. Okay, and we have got our UDL also. We have got our UDL. Just now the total load 240, it was sorry, 200 divided by your total this span. We got our this UDL This we got it to be how much? 13.33. Just now we calculated 13.33 kilonewton per meter. This was our UDL of the load, which is total load. Now, once we know this thing, you can obviously calculate your reactions RC and RD. You see here, the reactions have been calculated. The total reactions RC, this is RD, okay, RC RD. So this is 240 is equal to 240 plus will be this 13.33 into your 15 meter. So from here, if you calculate taking moment about C, if you calculate, sorry, moment about D, if you calculate, you can find out your RC. Reaction will come out RC into 15 minus 240 into 15 minus 1.2. If you do, then you have your minus this 13.33 divided by 15 by 2, 15 into 15 by 2, we will get our RC value. This is our maximum reaction. Once you get your RC, you can calculate your RD value also, you can calculate. So we have calculated here RC as well as RD. We have calculated our RC and RD value, and what we found that this is our maximum reaction. That means our maximum load is 320.77 kilonewton. So we have calculated our, wait, one more thing, this is our reaction which we have calculated 32 maximum reaction. That means this is not the maximum load, but this is the maximum reaction here. So at each end of the crane girder there are two wheels, we know, right? So load on each wheel will be how much? Now this, since this is the reaction, maximum reaction is this, we have to divide this into two. Okay, since there are two wheels on the crane girder, at the each end of the crane girder, we know, if I talked in this way, girders were there, these are the cranes, there are two wheels on the crane, this side one, this side one, this side one, this side one. Okay, crane girder, this side one, this side one, crane girder, you have one wheel here on each leg. So how much is your this thing? This will be how much? If I show this one, load on each wheel, you can see here, load on each wheel is how much? 320, the maximum reaction, divided by 2. If you do, you will get it to be I'll I think I'll go next. Okay, it is gone. So load on each wheel we have calculated here. This, after getting the maximum reaction, we can get the load on each wheel, which is known as your static wheel load. Okay. So static wheel load, you have to know, this is known as your static wheel load, which is a load on each wheel. And you know, I talked about in the first class, I talked about the impacts which can be considered, and there was mentioned static load. So this is your static wheel load. Okay, remember the load on each wheel is your static wheel load, is known as your static wheel load. Now see, once we got the load on each wheel, we will see in IS 875 part 2 clause number 6.1 page number 15. Okay, there we will get what increase. I told you that the 25% for impact load, it is taken, assumed to be, it is taken, the impact factor allowed is 25% for this thing. Okay, so for the loads, vertical loads, so design load will be how much now? 1.25 into this 1.25. Why? Because 25% is added, so it is 1.25. It was 100% 1, but now it is 1.25. 25% is added, so 1.25% of the this load is your increase on the impact factor on each wheel. Now this is how much? So now load on each wheel after this adding the impact allowable